Assalamualaikum warahmatullahi wabarakatuh. First of all, I'd like to introduce myself. My name is Siti Hanisa binti Muhammad Anafia and my metric number is DE1600004. Today, I am going to present my final year project 2. My project title is Simulation of the Concrete Material at Microwave Frequency using CST software. I have divided my presentation into 6 sections. They are Introduction, Literature Review, Methodology, Results and Discussion, Conclusion, and Recommendations. I like to begin with my first point. The first section in this presentation is Introduction. I will explain the background of the project. The idea of improving the quality check technique came from the lack of suitable methods and techniques used for quality checking. Good quality tile roof is a tile roof that has no void or air bubble inside the body of sample. There are several methods used for determining the quality of tile roof. Next, the problem statements of the project. Tile roof quality check are still being done by using old trick, that is by listening to the sound produced when tile roof are hit with the hammer. This old method requires workers to listen to the sound produced when tile roof is hit with hammer. The amount of force used varies with each workers, as it is impossible for each of them to hit the tile roof with the same amount of force. The judgment of sound in which workers may have different judgment on what is the minimum specification of the good quality of tile roof. The objective of this project is to design and characterize the roof tile by using CST software. Next, to design and develop a system that can detect quality of tile roof. And lastly, to demonstrate the functionality of tile roof quality detection system. The scopes for this project is a quality detection system simulation is performed by using the electromagnetic full wave simulation software CST Microwave Studio. Design a free space measurement system with the frequency range of 2.2 GHz to 3.3 GHz. Investigate the parameter of S parameter, reflection coefficient, and resonant frequency. And lastly, analyze the effect of different size of defective material on the resonant frequency. Next, I am going to talk about the literature review, which is the second section in this presentation. Microwave non-destructive testing (MNDT) is used electromagnetic wave for locating the hidden object in a material. This technique involves the development of sensor method and calibration technique for detection of defect, void, and cracks. The term microwave describes as the alternating current signal with its electromagnetic wave with frequencies between 300 MHz to 300 GHz. There are two type measurement techniques available at microwave frequencies, which are first, free space method, and second, waveguide method. The free space method, operating in the far field region, employs spot focusing horn lens antennas. For the waveguide methods, operating in the near field region, employ open-ended coaxial lines, rectangular waveguides, microstrip lines, and cavity resonators as probes. Concrete roof tile is a material composition and combination of sand, cement, and water. There are two types of concrete roof tile, which is flat or curved. The advantage of this concrete roof tile is lower cost. Horn antenna consists of a flaring metal waveguide shaped like a horn to direct radio waves in a beam. Horn antenna can be E-plane horn, H-plane horn, and EH-plane or pyramidal horn, depending on the direction of flaring microwave horn antenna. Reflection coefficient S11 represents how much power is reflected from the antenna and also known as gamma or return loss. Next, I am going to explain about the methodology of this project. This is the flowchart of the project. Begin with the design horn antenna and material under test. After that, create the defect in the MUT. Next, CST simulation, and after meet requirement, analyze the result and discussion. The proposed structures in this project are the Free Space Microwave Measurement System FSMM as shown in this figure. Two horn antennas are used as transmitter and receiver respectively, and the concrete tie roof is placed in between the horn antenna as the material under test. The simulation was carried out over a frequency range of 2.2 to 3.3 GHz. Two horn antennas are using in this simulation. One horn antenna acts as the transmitter and the other one acts as the receiver. The horn antenna design facing to each other in the CST Microwave Studio software. Concrete tie roof is the material under test for the free space measurement system in this project. This material were placed in between the horn antennas. The length and height of the concrete tie roof is designed to have 330 mm and 420 mm respectively. The thickness of the concrete tie roof is 20 mm. This figure shows free space microwave measurement system design in CST Microwave Studio software. This is the block diagram of the project. The input for the system is the defective material under test MUT. The process for this project is free space method simulate using CST and to detect defect. And the output of this project is reflection coefficient and resonance frequency. Computer Simulation Technology CST Microwave Studio software is the main software to accomplish this project. This CST software will help to design the free space microwave measurement system and simulate the design. For the analysis part, Microwave Excel will be used and the other tool needed in this project is a personal computer. Next, I will explain the result and discussion. This figure shows the non-defective and defective material under test. The defect that introduced in the material under test has different shape and dimension and also created in different location in the material under test. Defective MUT-A is the defect in shape of cylindrical created in the center of material. For defective MUT-B, the defect in form of two cylinders are created in the material under test. This figure shows the reflection coefficient versus resonance frequency for non-defective MUT and defective MUT-A and B. The first resonance frequency is non-defective MUT, recording negative 46.966 at 3.112 GHz. After the MUT is introduced with the void, which is defective MUT-A and B, the resonance frequency is shifted to the right. This is clearly show that when there is void in form of cylinder in the MUT, there will be a change to resonance frequency. This graph shows the correlation of radius of the defect to the resonance frequency. From the result, it is observed that when the radius of defective MUT-A increase, the resonance frequency will increase. This graph shows the correlation of the height of the defect to the resonance frequency. It is observed that resonance frequency varies at different height of cylinder. The resonance frequency has a certain tendency to increase with the increasing of height of cylinder. This figure shows the defective MUT in the form of rectangle. Defective MUT-C and defective MUT-D has a different dimension of rectangle. This figure shows the reflection coefficient versus resonant frequency of non-defective, defective MUTC and defective MUTD. Simulation point out that when there is void in form of rectangle in the MUT, there will be a change to the resonant frequency. This line graph shows the correlation of height of the defect to the resonant frequency. It clearly shows that the resonant frequency varies at different height of rectangle. As the height is increased, the resonant frequency will increase. Correlation of length of the defect to the resonant frequency is shown in this line graph. As we can see, the result indicate that while the length of the defect increase, the resonant frequency show a slightly increase. Defective MUTE and F were random defects that created in the MUT at different locations in the form of cylindrical and rectangular shape. This figure shows the reflection coefficient versus resonant frequency for non-defective, defective E and defective F. This result also show that when there are voids in the MUT, there will be a change to the reflection coefficient and resonant frequency. In conclusion, non-destructive technique by using the free space measurement technique is best for determining the reflection coefficient S11 at microwave frequencies. The defect in the material under test affects the resonant frequency of the microwave system. The last section of this presentation is recommendations. There are two recommendations that can be made into this project. The first is study on different materials such as clay roof tile using free space microwave measurement system. And the second is study on different frequency that can be applied to detect the defect in the material. In this video, I will demonstrate my project simulation using CST Microwave Studio Suite version 18. The proper structure in this project are the Free Space Microwave Measurement System, FSMM. Two horn antennas are used as transmitter and receiver, and the concrete tile roof is placed in between the horn antenna as the material under test. This is the non-defective material under test, which is no damage occur in this material under test. To simulate this free space measurement system, first click to the start simulation. After that, after complete the simulation, the result will show at S parameter. This is the result for the non-defective material under test. We can see the S11 and resonant frequency. Material under test were designed in different shape of material in which are in cylinder and rectangular. The defective MUT which were called defective MUT A, B, C, D, E, and F. Each of the defect has different shape and dimension as shown in this software. Defective MUT A has been created in the center of the material under test, and defective MUT B the defect is the shape of two cylindrical, and defective MUTC the rectangle shape of defect. Defective MUTD also in rectangle shape, defective MUTE in shape of cylindrical but at different location, and defective MUTF in shape of rectangle but in different location.